five-wire feeder is a set of conductors that includes three-phase conductors, a neutral conductor, and a grounded conductor. According to National Electrical Code Article 100.20, grounded conductor and neutral conductor are separate terms with distinct definitions. A grounded conductor is a conductor that is intentionally grounded to establish a known electrical potential reference. A neutral conductor is a conductor that carries no current under normal operating conditions but provides a path for current to flow under fault conditions. Based on these definitions, both the grounded conductor and the neutral conductor are considered part of the feeder circuit. Therefore, a neutral or grounded conductor would be counted as one of the 5 wires in a 5-wire feeder. A typical 5-wire feeder would consist of the following conductors: firstly, 3-phase conductors such as A, B, and C; secondly, a neutral conductor or N; and thirdly, a grounded conductor or P. In conclusion, a 5-wire feeder is an electrical circuit that includes 3-phase conductors, a neutral conductor, and a grounded conductor. Both the neutral and grounded conductors are counted as part of the 5 wires in this type of feeder. Let's delve deeper into the intricacies of these components and how they interact within the electrical system. When we talk about 3-phase conductors, we're referring to the primary current-carrying wires that deliver power from the source to the load. These are typically labeled as A, B, and C phases, each carrying alternating current that is offset by 120 degrees, ensuring a consistent and balanced power supply. The neutral conductor, often identified as N, serves as a return path for current in unbalanced 3-phase systems or single-phase circuits derived from a 3-phase supply. Ideally, under perfectly balanced conditions, the neutral conductor would carry minimal current. However, in reality, loads are rarely perfectly balanced, and the neutral conductor plays a critical role in handling the resulting current imbalances. The grounded conductor, sometimes referred to as the equipment grounding conductor (EGC) or protective earth (PE), is primarily for safety. It provides a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protective devices like circuit breakers or fuses. This grounding helps to prevent electrical shock hazards and minimize the risk of equipment damage during fault conditions. It is important to note the difference between the grounded conductor and the grounding electrode conductor (GEC). The grounded conductor, as discussed, is part of the feeder circuit. The grounding electrode conductor connects the equipment grounding system to a grounding electrode, such as a ground rod or water pipe, establishing a connection to the earth. This connection ensures that the entire electrical system is at a stable ground potential, further enhancing safety. Understanding the code requirements for conductor sizing and ampacity is also crucial. The National Electrical Code provides specific tables and guidelines for determining the appropriate size of conductors based on the anticipated load current, ambient temperature, and other factors. For example, NEC Table 310.16 provides ampacity ratings for conductors based on insulation type and installation conditions. Similarly, the code outlines requirements for overcurrent protection, ensuring that circuit breakers or fuses are properly sized to protect conductors from overheating and potential damage. Consider a scenario where a 5-wire feeder supplies power to a large motor. The 3-phase conductors would carry the bulk of the motor's operating current, while the neutral conductor would handle any current imbalance resulting from slight variations in the motor's windings or load. The grounded conductor would be connected to the motor's frame, providing a path for fault current in the event of an insulation failure. Proper installation and maintenance of a 5-wire feeder are essential for ensuring reliable and safe operation of electrical equipment. This includes regularly inspecting conductors for signs of damage or deterioration, tightening connections to prevent overheating, and verifying the integrity of the grounding system. Additionally, it is important to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the National Electrical Code and other applicable standards. The 5-wire system is not just confined to motor applications. It is frequently used in data centers, commercial buildings, and industrial facilities where there is a need for both 3-phase power and single-phase circuits. In such installations, the neutral conductor becomes even more critical as it handles the aggregate imbalance from numerous single-phase loads. Furthermore, The grounded conductor plays a vital role in protecting sensitive electronic equipment from voltage transients and electromagnetic interference (EMI). By providing a low impedance path to ground, the grounded conductor helps to shunt away unwanted electrical noise, ensuring the stable and reliable operation of electronic devices. The NEC also addresses the issue of harmonic currents in electrical systems. Harmonic currents are non-sinusoidal currents that can be generated by nonlinear loads such as electronic ballasts, variable frequency drives, and computers. These harmonic currents can cause overheating of conductors, transformers, and other electrical equipment, as well as interference with communication systems. The use of a 5-wire system with an appropriately sized neutral conductor can help to mitigate the effects of harmonic currents by providing a dedicated path for these currents to flow. In some cases, it may also be necessary to install harmonic filters or other mitigation devices to further reduce harmonic distortion. Another important aspect of 5-wire feeder design is voltage drop. Voltage drop occurs when the voltage at the load end of a feeder is lower than the voltage at the source end due to the impedance of the conductors. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in feeders and branch circuits. These guidelines recommend limiting voltage drop to no more than 3% for power, heating, and lighting loads, and no more than 5% for feeders. To minimize voltage drop, it is important to use appropriately sized conductors and to keep feeder lengths as short as possible. In addition to conductor sizing and overcurrent protection, the NEC also addresses the issue of bonding and grounding in electrical systems. Bonding refers to the practice of connecting all non-current carrying metal parts of an electrical system together to create a low impedance path for fault current. Grounding refers to the practice of connecting the electrical system to the earth to provide a reference point for voltage and to help dissipate fault current. Proper bonding and grounding are essential for ensuring electrical safety and preventing electrical shock hazards. The NEC provides detailed requirements for bonding and grounding, including the types of materials and methods that must be used. These requirements are designed to ensure that the bonding and grounding system is effective in providing a safe and reliable electrical system. When designing a 5-wire feeder, it is important to consider the specific requirements of the load that it will be serving. This includes the voltage, current, and power requirements of the load, as well as any special considerations such as harmonic content or sensitivity to voltage drop. By carefully considering these factors, it is possible to design a 5-wire feeder that will provide reliable and safe power to the load. Furthermore, ongoing education and training are crucial for staying up to date with the latest NEC requirements and best practices for electrical installations. The electrical industry is constantly evolving, with new technologies and regulations being introduced on a regular basis. By participating in continuing education courses and attending industry conferences, electricians and other electrical professionals can ensure that they have the knowledge and skills necessary to perform their jobs safely and effectively. This also involves understanding the proper use of testing equipment such as multimeters, clamp-on ammeters, and ground resistance testers. These tools are essential for verifying the integrity of electrical systems and troubleshooting problems. For example, a multimeter can be used to measure voltage, current, and resistance, while a clamp-on ammeter can be used to measure current without interrupting the circuit. A ground resistance tester can be used to measure the resistance of the grounding system, ensuring that it is providing adequate protection against electrical shock hazard. In addition to the technical aspects of 5-wire feeder design and installation, it is also important to consider the safety aspects. Electrical work can be dangerous, and it is essential to follow all safety precautions to prevent accidents. This includes wearing appropriate personal protective equipment such as gloves, safety glasses, and insulated tools. It also includes de-energizing circuits before working on them and verifying that they are de-energized using a voltage tester. Furthermore, it is important to be aware of the potential hazards associated with working around electricity, such as arc flash and electrical shock. Arc flash is a dangerous phenomenon that can occur when a short circuit creates a high-energy arc. Arc flash can cause severe burns, blindness, and even death. Electrical shock can occur when a person comes into contact with an energized conductor. Electrical shock can cause muscle spasms, cardiac arrest, and even death. By following safety precautions and being aware of the potential hazards, it is possible to minimize the risk of accidents when working with electricity. The 5-wire feeder system, while seemingly straightforward, is a critical component of modern electrical infrastructure. Its proper design, installation, and maintenance are essential for ensuring the safe and reliable operation of electrical equipment and protecting people from electrical hazards. The combination of 3-phase conductors, a neutral conductor, and a dedicated grounded conductor provides a robust and versatile solution for powering a wide range of loads, from large industrial motors to sensitive electronic devices. By adhering to the NEC guidelines and best practices, electrical professionals can ensure that 5-wire feeder systems are installed and maintained to the highest standards of safety and performance. And remember, both the grounded and neutral conductors are crucial components that contribute to the overall functionality and safety of the system.